What is best, developing hardware design requirements up front as part of planning, agilely during the design process, or a hybrid of them both? This video explores how and when to develop hardware requirements. Hello, I'm David Ullman. I've been designing products and teaching others how to design products for over 40 years. My book, The Mechanical Design Process, is used internationally as the standard for product design education. Recently, I've been using the Scrum framework to help manage the design process and wrote a book on this also. Whether using traditional plan design methods, the Scrum framework, or a hybrid of the two, understanding the product's requirements is very important in terms of design time, cost, and product quality. In these videos, I weave together the planned with the agile to give you a solid framework for developing good hardware requirements. By hardware, I mean everything but software. However, what I will tell you here will interface well with your software colleagues. This final video gives guidance on how and when to spend time and resources developing hardware requirements. The first video sets out a framework with 4 key conversations needed to define a requirement. What is being designed, for whom, what does it need to do, and how will you prove the need is met? Any requirements development methodology needs to facilitate these 4 conversations at a minimum. The second video focuses on developing requirements up front as part of a traditional product planning. It introduced how the quality function deployment, also known as the QFD or House of Quality method, can support the 4 key conversations, but the video barely scratched the surface of this method's value. The third video focused on developing requirements on the fly, agilely using customer stories to facilitate the conversations. As discussed in the earlier videos, the 2 methods, QFD and Agile Stories, are very synergistic. Let's compare how well each of the methods support the key conversations. QFD does well with the bonus of an additional conversation on how the requirements are currently met by existing systems. Stories, while quicker to develop than QFD, are not as strong in refining measures and targets for hardware systems. A caveat here. One problem with developing requirements up front is that numerous studies have shown that they are often changed during the design process, and changes not updated in the documentations are well managed. Balancing the good with the bad of each of these approaches is the challenge. So the question addressed here is how much effort should be devoted to developing requirements up front versus agilely during the project? Answering this question is the goal of this video. The answer lies in the following 8 guidelines. Guideline 1. If a feature is regulated by standards, then it must be planned up front. Standards could be from a government, standard associations, other organizations, the company, or from the team itself. There's no excuse for not knowing the applicable standards up front. Guideline 2. Planning methods work well for mature types of products when the uncertainty is low. If you design and produce a family of electric motors, for example, producing a new motor will only have uncertainty in areas with new functionality or technology. Guideline 3. Modules or systems that may exhibit volatility, uncertainty, complexity, or ambiguity are best served by agile methods. Design is learning, and you can't write a requirement about what you don't know about or cannot control. Guideline 4. Top-level system-wide requirements usually span many subsystems or modules, and thus many interfaces between them. They must be planned to ensure communication. Guideline 5. Requirements are all about key conversations. If the conversations need to be across an interface, then the requirements must be planned and coordinated with those responsible on all sides of the interface. Guideline 6. Once the interfaces to other systems and users are fixed and stable, agile methods suffice within a module. Care must be taken so that any story that affects other modules through an interface is coordinated with all who are responsible. Guideline 7. A drawback to agile requirements is that they have little throttle to control feature creep. The Scrum methodology, by its very nature of adding incrementally more function to a product, both manages this and to some degree encourages it. Care must be taken. Guideline 8. Do not allow over-the-wall requirements dictated by the customer. In the first video, I defined a requirement as a shared understanding and discussed how the 4 key conversations build good requirements. Thus, you must do everything possible to build these conversations and break down the wall. One example of applying these guidelines is Saab development of the Gripen E fighter. This aircraft was designed by more than 1,000 engineers organized into more than 100 Scrum teams. Before the teams began work on this airplane, there was extensive effort developing 300 high-level requirements for the entire aircraft. These requirements were established in tight coordination with the Gripen's customers. The oxygen system manager, for example, was responsible for 15 of these requirements. His design teams developed all the detailed requirements just in time as part of their Agile process. Above him, planned requirements. Below him, Agile processes developing requirements with stories. In summary, follow the 8 guidelines to determine which requirements to plan and which to allow to evolve just in time during development. Further, periodically review the planned requirements and update them as needed. If a module has been defined with fixed stable interfaces, leave the requirements driving the development of that module to the design team. Finally, developing good requirements requires about 7% of the total time to develop the product. Keep this in mind when you're developing requirements. Thank you for listening. Be sure to subscribe so that you don't miss the next video on hardware design best practices.